Welcome students. Today we will be covering Rolle's theorem, Lagrange's mean value theorem and Cauchy's mean value theorem. So all these three theorems are important as far as GATE examination point of view and as far as academic perspective for your BTech semester examination. Okay, so let's first study what's Rolle's theorem. Rolle's theorem. So in all the theorems, basically there are certain conditions which has to be satisfied. Okay, so let fx be a function defined in the range a to b such that it should satisfy the three conditions that fx is continuous in a to b. Second, fx is differentiable in fx is differentiable in a to b. And third condition is function values at the outer point should be also equal. If these three conditions are satisfied, then there exists at least one value of c which lies in the range of a to b such that derivative at that point is 0. So f dash c is 0. So what's the three condition? This is the three condition it should satisfy, and conclusion that the derivative at that, but there should be at least one point between those two interval a and b such that derivative is 0. If we want to understand this thing as graphically, then we can say this is the condition. Let us say these are the two graphs possible. Let us say this is a graph. Okay, this is point a, this is point b. There might be some other graph as possible. Let us say b point and a point. So here you can see in between a and b there is a single point where the tangent is possible, means that derivative is 0, and here 2 points are possible. So it is mentioned that at least one value should be in the range of a to b where the derivative is 0. Derivative means that tangent, it should make a tangent at that particular point. Remember one thing, if any of the condition is not satisfied, if any of the condition is not satisfied, then Rolle's theorem is not valid. Rolle's theorem is not valid. Okay, let's move on to some questions just to get the more clarity. Let us say a first question is this. Question number this, that is, verify Rolle's theorem for fx is equals to x minus 1 and x minus 2 whole square in the range of 1 to 2. So what is function fx? This is the function fx and it's definitely a polynomial function. And what's the range a to b? This is a1 and this is b2. Okay, so what are the three conditions it should satisfy? That it should be continuous in nature, it should be differentiable, and the value at the end point should be equal. So let me describe one question for your academic point of view, because you have to score marks in the semester examination. So you will write in such a manner that since fx is a polynomial function and we know that the polynomial function is always continuous in nature, fx is a polynomial function and it is continuous in nature, hence fx is continuous. Okay, as we know that polynomial function are always continuous everywhere. Okay, let's talk about the second point. We also note that the polynomial function fx is a polynomial function, and polynomial function is always differentiable in the given range. Okay, so the first two conditions are satisfied. Let's talk about the third condition. What is the third condition? That the value of the function. So what is fx? Fx is nothing but x minus 1 and x minus 2 whole square, and this is 1 minus 2. 1 to 2 is the range. Okay, so let's calculate the value of f1. You can see if we'll put the values in the given fx, you will find it 0. If we'll find 2, then you will also find it 0. So the third condition, that fa is equal to fb, is also satisfied. So you will write like this: since all the three conditions of Rolle's theorem are satisfied, hence there should be at least one value of c which lies in the range of 1 to 2, such that f dash c is 0. So first of all, we have to calculate the f dash x. So what is fx? Let me write it once again: x minus 1 into x minus 2 whole square. So let's do the differentiation. How do we differentiate? Let's consider this as one part, consider this as two parts. So x minus 1, what is the differentiation of x minus 2 whole square? This is 2 into x minus 2 plus x minus 2 को constant and x minus 1 का differentiation 1. So if we'll solve this one, this will come out to be x minus 2 and 3x minus 4. Take the things common, because x minus 2 is also common here, x minus 2 is also common here, and solve it. So can we say f dash x is 0? So what is f dash c? F dash c is, put the value of x as c, so c minus 2 and 3c minus 4. And what is the condition? It is saying that f dash c should be equal to 0. So can we say we are getting two values of c is 2 and c is 4 by 3. But the clause is this: our value should lie in the range of 1 to 2. So which value is lying? This is lying outside of the interval and this is lying inside of the interval. This is because 1 to 3. Hence there exists one value of c in the range of 1 to 2, such that f dash c is 0. Hence Rolle's theorem is verified. Okay, clear? Now let's move on to the next part, second question based on the Rolle's theorem. So what's the next question? Question is: verify Rolle's theorem for the function fx is equals to sin x upon e to the power x, and the range is given as 0 to pi. Again the three condition: since the given function is trigonometric as well as exponential function, and we know that the summation or division or multiplication of the continuous functions are also the same. So since trigonometric or sine function and exponential function are continuous and differentiable both, hence the two conditions are satisfied. Hence the two conditions are satisfied, but we'll have to check for the last condition, that f of a should be equal to f of b. So what is a? A is 0 and b is pi. Okay, so f of a, if we'll calculate, this is nothing but f of 0, and this is sine 0 by e to the power 0. So sine 0 is 0, e to the power 0 is 1. Can we say 0? Okay, let's calculate the f of pi. So sine pi upon e to the power pi. Sine pi is nothing but 0 e to the power, so 0 divided by anything is 0. The third condition is also satisfied, fa is equals to fb. So since the both condition, third three condition, that is continuous, differentiable, and the values of function at the endpoints are also equal, hence there must be at least one c lies in the a to b such that f dash c is equals to 0. Clear है? So what is fx? Fx is nothing but sin x divided by e to the power x. So what's the derivation? This is differentiation. So how do we differentiate this? If d by dx of a by b, how will differentiate this? This is b square b into dA minus a into db. Okay, so e to the power x का whole square and this is e to the power x cos x minus sin x into e to the power x. If we'll take the e to the power x as common, can we say cos x minus sin x, and can we write this as e to the power x? So one ex will cancel out, and what is your f dash x? This is nothing but cos x minus sin x divided by e to the power x, and this should be equal to 0. Can we say f dash c? So what dash f dash c? Cos c minus sin c by e to the power c is 0. So denominator cannot be 0, hence making the numerator as 0. So cos c minus sin c is equals to 0. Can we say tan c is equal to 1? And tan c are what is the value of c? Can we say c is nothing but 45 degree or pi by 4, and pi by 4 is definitely lying in the range of 0 to pi, hence the c is the only value which at which the derivative of the function is 0. Okay, now let's talk about the second theorem, that is Lagrange's mean value theorem. It is, all the theorems are similar in nature. Okay, what's the theorem? Let me write it for you. Let fx is defined in the range a to b and it satisfies the following condition. It satisfies the condition is that function should be continuous. Second, function is differentiable. Okay, and if these two, here the compulsority of the end function values at the endpoint is equal as in the Rolle's theorem, it is not required here. Then there exists at least one point C belonging to A to B such that f dash C is equal to f of b minus f of a divided by b minus a. Okay, so this is Lagrange's mean value theorem. Let me focus on a numerical to get it more clarity over how will you solve in the semester examinations. So this is a question: verify LMVT for the function fx is equals to x square plus 2x plus 3 in 4 to 6 and find c. Okay, you have to find the c at which the Lagrange's mean value theorem satisfied. So as you can see, it's a polynomial function, so you will write that fx is polynomial, hence it is continuous. Okay, second condition is, again, if it is polynomial, then polynomial function is always differentiable, as already we have covered this. Okay, so these two conditions are satisfied. Then there exists at least one value of C in the range of a to b such that it satisfies f dash c is equals to f of b minus f of a divided by b minus a. So can we say this is a, this is b? Okay, so we will be needing the values of function at 4 and 6. So fx is x square plus 2x plus 3. F of 4 will be 4 square plus 2 into 4 plus 3. Can we say this is nothing but 16 plus 8, 24, 3, 27, and f of 6 is 6 square plus 2 into 6 plus 3. Can we say this is nothing but 51? So let f dash c, f of b is 51, f of a is 27, and b is 6 minus 4. Can we say this is nothing but 12? So we know that f dash is 12, but what is f dash c? So f of x is f dash x is 2x plus 2. So can we say f dash c is nothing but 2c plus 2, and equate the same. 2c plus 2 is equal to 12, and from here you will find the value of c, and this is being answered in the question. Okay, now let's move on to the last theorem, that is Lagrange's mean value Cauchy's mean value theorem, which is just a extension of the Lagrange's mean value theorem. So Cauchy's mean value theorem. What does Cauchy's mean value theorem basically consider? Two functions. Okay, if fx and gx are two real valued functions such that first clause is similar, fx and gx are continuous. Second condition, fx and gx are differentiable. Okay, then there exists at least one point of c lying in the range of a to b such that f dash c divided by g dash c is equal to f of b divided by f of a and g of b divided by g of a. Okay, this is the condition you have to remember. Okay, so again let's focus on a numerical question. Is like this: verify Cauchy's mean value theorem for the function e to the power x and e to the power minus x in the interval a to b. Okay, so can we say this is fx, and can let us assume this is gx, and we know that exponential function are continuous as well as differentiable. Okay, hence the first two conditions are satisfied. So can we say our fx is equals to e to the power x and gx is equals to e to the power minus x. Okay, so f dash x is nothing but e to the power x, and g dash x is equal to e to the power minus x, and it will be multiplied by minus 1. Okay, because minus x, x is there at the exponent. Okay, so what does Cauchy's mean value theorem? That f dash c divided by g dash c is f of b by f of a divided by b minus g of b minus g of a. So before calculating this, let me do it easy for you. We will be needing f dash c. So can we say it is e to the power c, and g dash c is nothing but minus of e to the power minus c. Clear? And let us say simultaneously calculate f of b. So f of b is nothing but e to the power b, f of a is nothing but e to the power a, g of b is nothing but e to the power minus b, g of a is nothing but e to the power minus a. What we did, we just substituted the values in these functions. Okay, now put all the values. So f dash c is e to the power c, and this is e to the power minus c, and f of b is e to the power b minus e to the power a divided by e to the power minus b minus e to the power minus a. Okay, so let's take this thing at the top. So can we say this is e to the power c plus c, and this is e to the power b minus e to the power a. Okay, and can we say this can be also written as 1 upon e to the power b, 1 upon e to the power a. Okay, and can we say e to the power b e to the power a divided by e to the power a minus e to the power b divided by e to the power a into e to the power a into e to the power p. So this will go at the top. We can write the same e to the power b e to the power a e to the power a minus e to the power p. Okay, and this is e to the power a plus b. Okay, now if we remember, this is e to the power a. Okay, if we'll remember, this will get cancel out. Okay, or remember one more thing here, g dash c was minus. Okay, so minus e to the power 2c, and if we'll take minus as common, can say minus is common as e to the power a minus e to the power b divided by e to the power a minus e to the power b e to the power a plus b. So this will cancel out, minus minus will cancel out, and can we say e to the power 2c is equals to a to the power a plus b, or can we say on in taking the log 2cb is equals to a plus b, and c is a plus b by 2. So this is the answer which you wanted. Okay, so let me summarize the things for you. What we did, we Rolle's theorem, we did Lagrange's mean value theorem, we did Cauchy's mean value theorem. So what was the condition? That fx is continuous. Okay, fx is differentiable, and f of a should be equal to f of b, and if these three conditions are satisfied, then there exists a point c in the range of a to b such that f of c is 0. Okay, let us talk about the Lagrange's mean value theorem. Here fx should be continuous, fx should be differentiable, only these two condition is needed, and c in the range of a to b, then f dash c is given as f of p minus f of a divided by b minus a. In the Lagrange's mean value theorem, if there are two function fx and gx is continuous, and there are two function fx and gx is differentiable, then there exists a c in the range of a to b such that f dash c divided by g dash c is equal to f of p minus f of a and g of p upon g of a. So this is all about the Rolle's theorem, Lagrange's mean value theorem, and Cauchy's mean value theorem.